We've learned quite a few different factoring techniques, but whenever we look at a problem that needs to be factored, we rarely are told which factoring technique to use. The directions are usually just factor this. And so what I want to talk about is what should we do whenever we get a factoring problem and we're just told, hey, factor this. And so the first step for any factoring problem, no matter what, is to find the greatest common factor. And so in this first problem, it's a binomial. We've got two different terms, a 9x to the fifth and a 36x. And so the first thing that we want to look for is a greatest common factor. And this binomial has a greatest common factor. 9 and 36 are both divisible by 9. And then x fifth and x are both divisible by x. So this has a greatest common factor of 9x. And so step number one is to factor out that greatest common factor. This is going to lead us to x to the fourth minus 4. So after we factor out a greatest common factor, then we start looking for another factoring technique. And so question number two is this a trinomial or a binomial? And so if it's a trinomial, we are going to go for usually two parentheses. And if it's a binomial, also two parentheses, but binomials typically have a shortcut. So if it's a binomial, which in this case it is, we're going to call this step 2a. If it's a binomial, then we are looking for perfect squares. Do we have perfect squares? And in this case, we do. X to the fourth and 4 are both perfect squares. So that means we can leave our 9x where it is, and we can go with two sets of parentheses here. The square root of x to the fourth is x squared. And the square root of 4 is 2, of course. And since this is a difference of squares, we've got 1 plus and 1 minus. Okay, great. So before we stop and say, hey, we're done, the next step, I'm going to leave a space here for 2b, which I'm going to do in a minute. Step number 3 is, are we done? And in this case, the answer is no, because of these two parentheses we came up with, one of these sets of parentheses can be factored again. Right here, we have an x squared. And so can we factor that again? Is that another example of a perfect square? Let's go ahead and take a look at it. X squared is a perfect square. What about 2? Is 2 a perfect square? No. And so we need to check and say, are we done? Is there something else we could factor? But in this case, there's not something else that we can factor. It looks like maybe we could because we get an x squared and a minus, but because 2 is not a perfect square, we can't factor that. And so this right here is our final answer. So we want to make sure that even though we have two parentheses, is there anything else we could do with those two parentheses? Now, part 2b, if this had been a trinomial, then we're going to go to our two parentheses. And the two parentheses, that's another ball of wax. When we have our two parentheses, we would look for, is there a leading coefficient? Is it like a 3x squared, or is it just x squared? And so we've got a couple of different techniques for trinomials. Let's look at this second problem. 6x cubed plus 30x squared minus 24x minus 120. Again, step number one, is there a greatest common factor? And the answer here again is yes, there is. There is a greatest common factor. They don't all have a variable, but 6, 30, 24, and 120 are all divisible by 6. So we can bring a greatest common factor out of here, leaving us with x cubed plus 30x squared minus 24x minus 120. Oh, dang. Wow. Okay, so I divided the first thing by 6, but none of the rest of the stuff. Way to go, Taylor. You are such a smart guy. 5x minus 4x minus 20. Let's divide everything by 6. Okay, there we go. So there it is with the greatest common factor removed. Okay, is it a binomial or a trinomial? No, the thing we're left with in parentheses has four terms, and four terms means we're going to now factor by grouping. Factoring by grouping is what we do if there are four terms. So what does factoring by grouping mean? It means take these first two terms, x cubed plus 5x squared, and what's the greatest common factor of x cubed and 5x squared? Well, that is just x squared, leaving us with x plus 5. Great. And then we'll look at our second set, which is negative 4x squared minus 20. So the greatest common factor there is 4, but because it starts with a negative, we're going to factor out a negative 4. So negative 4, leaving us with, hey, what do you know, x plus 5, which is great news for us. Both of these groups that we got have a factor of x plus 5. So one of our parentheses will be x plus 5. And the other parenthesis will be x squared minus 4. And then don't forget, we had that 6 out in front, our greatest common factor. And now we still ask ourselves that last question, are we done? No, because it looks like we've got an x squared still that we might be able to do something with. This x squared minus 4, let's see if we can factor that. So that's a binomial. Is it a perfect square? Yes, it is. X squared minus 4 is a perfect square. The square root of x squared is x, and the square root of 4 is 2. And it's a difference of binomials, so plus minus. And then we've got that x plus 5 in the front, and then we've got our 6. So this actually factors, believe it or not, into 3 parentheses, and there's our solution there. So both of these problems that we did with factoring are what we would describe as factoring completely. Factoring completely means you use all of the techniques that we know for factoring and you just factor until there's literally nothing left to factor. You just go and go and go until the stuff that you're left with cannot be factored anymore, and then that's your final answer. In the first problem that we did, there was a greatest common factor, and then we had a difference of squares, so we were able to go two parentheses, and then there wasn't anything left to do. In the second problem we did, there was a greatest common factor, and then we factored by grouping. But then after we factored by grouping, we had a difference of squares, so we could use a third factoring technique, which was that difference of squares technique, giving us three parentheses and a greatest common factor.